This video shows how quick and easy it is to build simulations for Golden Dome using Ansys STK. We'll start out by creating a Golden Dome dome. And we're going to use start off with the location at AGI headquarters in Exton, Pennsylvania. And we're going to go ahead and insert a sensor dome on this location. Let's go ahead and open up the properties and change the settings here to mimic an actual radar dome. We'll go ahead and give our radar dome a range constraint of, let's say, 2,500 kilometers. All right, well, that looks pretty good, but the whole purpose of Golden Dome is to protect the entire homeland, so let's go ahead and move the default location to the center of the US. There we go. But this is not a Golden Dome, so let's go ahead and make this gold. Maybe change the settings a little bit so that you can still see through it a little bit. There we go. So clearly Golden Dome is a metaphor. It's not an actual Golden Dome. This is more of a example, notional dome you might see in traditional missile defense systems. But the real system is going to have much more complex assets, including a space layer. But the whole purpose of the Golden Dome is to protect the homeland from potential threats. So let's go ahead and just insert a notional threat here. And we're just going to click out a couple of random points. All right, and we're going to go ahead and change some of our graphics settings. Actually, our trajectory is a little high at the moment, so why don't we go ahead and bring that down a little bit to the minimum delta V for a ballistic trajectory. All right, so we're going to go ahead and clean up our graphics here, and we'll only show the trail of our trajectory. And we'll turn off the ground track. All right, so now we've got a notional threat, we've got our Golden Dome system, and we can do some basic analysis if we'd like, and we could say, when does this threat enter this Golden Dome and in what direction? So here we can see the time that it enters our dome, which is right at that 2,500 kilometers as we set the range to be, and this is the associated azimuth and elevation. But what we wanted to do was to create a simulation that really shows the new aspects of the Golden Dome system, and a big key component of that is the space layer. So what we're going to do is we're also going to add in a satellite and look at a sun-synchronous orbit and see if that would be able to help us with the threat detection. The default satellite is on the other side of the Earth, which kind of goes to show that the system really depends on the satellites for tracking and for potential intercept to be at the right place at the right time. And this is where it's really powerful to use STK as a what-if tool for running analysis, running trade studies. So to help illustrate that, I'm going to bring in just a whole bunch of satellites, and I'm going to we're going to start with a pretty robust constellation. Let's just say 25 satellites. And we'll give this a name, Golden Dome Sats. All right, so now we've got our constellation of 25 satellites. If we go back, we can see as they orbit, and we can see what the different detection scenarios look like. So in order to do analysis for this, you insert a chain object, and you can use this chain object to calculate when our potential threat is in view of any potential satellites. And you can already see the calculation happens instantaneously throughout the entire analysis interval. And you can see the various satellites that have the ability to track this satellite and potentially intercept it. So in order to actually pull the analysis out of this, there's a report and graph manager, and we can create a bunch of reports and graphs. But one of the things that we want to do is not just calculate when we can see these satellites, but what is the optimal strand? So for example, what is the closest satellite, or processing delay, or other things, but I'm just going to do the closest distance. And when you do that, you can go to your report and graph manager, and you can create an optimal strand value, and this shows the distance to the threat from any of your satellites. So it's anywhere from 2,000 and 4,000 kilometers away. And so that is how you quickly can perform some analysis on how well a space layer can help with the next generation missile defense system. And then the nice thing is, once you've built this quick simulation up, you can now go ahead and make changes, and you can see the minimum line there in green. But what if, for example, I wanted to change this, and I wanted to say, let me give me 100 satellites. Instead of 25, give me 100 satellites. There you see there's a lot more opportunities here. You can see the green line is moving between the various satellites much faster. And we can go back to our graph, and we can recalculate it. And now instead of getting up to 4,000 kilometers, we're keeping it well under 2,000 kilometers. So that's a much better design for this system. So that is a quick analysis you can do with STK to help with the Golden Dome simulations.